Okay, so the purpose of this video, this series of videos, is going to be to introduce you to the concepts and practice of using microcontrollers. Now, microcontrollers are really handy little devices, right? They're very small, these tiny small boxes, with lots of pins coming out of them, and a microcontroller is a device that we can give a set of instructions to, and that microcontroller will carry out those instructions one after the other. You get all sorts of different microcontrollers supplied by all sorts of different people. If you search for what is a microcontroller on Google, you'll get, I'm trying to think, microchip. There's microchip, right? Microcontroller, microprocessors. These are all words that mean the same thing essentially. A microcontroller is a small computer on a single chip. Let's miss out all that other text. A microcontroller contains one or more central processing units along with memory and programmable input-output peripherals. Now, a lot of horrible language in there. Let's make a distinction first of all. We're going to do a bit of programming, and for a lot of people programming means software programming. So you sit at a computer and you do a bit of typing and this stuff happens on the computer. So maybe you program an app that lets someone carry out calculations of whatever, or you program an app that lets someone play a game, or you program an app that lets someone link up with all their friends and share photographs and social network. All of that stuff happens on a computer. That's not the kind of programming that we're going to do. So we are going to use a computer to do programming, but then after we've written our program, we should see stuff in the real world, right? This is called hardware programming. So you've got to understand the difference between software and hardware. Software is something that happens inside a computer and is displayed on a screen. Hardware is something that happens in the real world. You need devices connected to the computer, and devices will do stuff. The type of devices that we'll connect are light emitting diodes, buzzers, motors, solenoids, heating elements, that kind of thing. Things that cause changes in the real world. And we've already seen this in systems. So this will be the first place that maybe you would have seen a microcontroller mentioned. It's perhaps in a subsystem diagram that looks something like that. It's a bit messily drawn. A microcontroller in the middle. And at the time we would have told you that a microcontroller is a device that you use when you've got a system that's got lots and lots of inputs and lots of outputs, right? And this is for hardware control in the real world. The whole point of this is that we're going to see things happen in the real world. So a heating element is going to cause temperature changes in our environment. A motor is going to make something move in our environment. A buzzer is going to make sound that we hear in the real world. Yeah. So we are not doing software programming, we are doing hardware programming. So what does a microcontroller look like? So a microcontroller looks like a wee black box with silver pins coming out of it, right? So there's images of a microcontroller there. This is the kind of style that we are going to use. It's called dual inline. We've got programmable boards that we'll use in the classroom. Got them here. Here's one. Crash by mop. So this is the kind of thing we use. There's the microcontroller right in the middle. The board's laid out like a nice wee system. Inputs on the left hand side. So there's a light sensor and a potentiometer and a temperature sensor and a couple of switches. Inputs, outputs on the right hand side. So there's a bunch of light emitting diodes, a wee 7-segment display that we'll play about with, a buzzer, a wee pixel buzzer, and a motor. We've got a motor connected to the board as well, so we've got a bunch of outputs on there. And then in the middle we've got processes. This guy here is our microcontroller. So that's what a microcontroller looks like in real life. And as I said, it's a device that we use to detect inputs and control outputs. It doesn't have to detect inputs, but we'll pretty much always use it to control outputs. We'll discover why we don't always need to look at outputs. Why we don't always need to look at inputs. We'll talk about that relatively early on. So that's when we're in the classroom and we're doing it practically. We can also, and we will also, do simulations. So what's nice is in Yenka, which is free software, you can download it, use it at home. What I've got on the screen right now is a simulation of that board I just showed you. We've built that in Yenka. So obviously there's a bunch of components hidden, but that's the same thing. There's the microcontroller in the middle, and there's the sensors, the light sensor, the heat sensor, the potentiometer, the buttons. There's the 7-segment display, there's the light emitting diodes, the pixel buzzer, all that kind of stuff. And if I wanted, I could connect a motor to any of these things. So that's what it looks like in real life, that's what it looks like in simulation. This here on the screen, this hello world, this is a flowchart. This is what our instructions look like. What I want you to do is just take a few moments to read that, pause the video and look at that flowchart and see if you can work out what's going on. I'm going to tell you what's going on after you've paused it. So I want you to pause it and then unpause it, and then I'll count down to 3 and then I'll tell you what's going on. So I want you to put a little bit of thought into this, right? So pause the video now. Now you've unpaused it. So 3, 2, 1, here's what's actually happening. It says set output 0 on. So if you look at that microcontroller, you can see that the outputs are labelled and there's output 0 down there. And then it says wait 0.2 seconds. And then it says set output 0 off and then wait 0.2 seconds and then go back. And just keep doing that over and over again. There's an infinite loop. So basically that output 0 would be going on and off every every fifth of a second. As it stands right now, that pin 0 is connected to maybe a few things on here. It's connected to one of the segments on that 7-segment display. It's connected to that light emitting diode. So if those things were switched on, then that light emitting diode would be going on and off every 200 milliseconds. And that's a really nice kind of lead-in to how good microcontrollers are and what they do that we can't do. That microcontroller could switch that pin on and off every exactly 200 milliseconds. Over and over again, forever, if we kept the power on. A human being couldn't do that. A human being wouldn't be exact enough to get the 200 milliseconds every time, and a human being's going to have to go to the toilet, go and get something to eat, sleep, you know, do something that fulfills their life at one point, right? This is why we use microcontrollers. They're faster than us, and they don't get bored, okay? And they're far more accurate than us. Right, so there's 5 questions. What is a microcontroller? Why would we use a microcontroller? That's a different question. See that? Why would we use a microcontroller? And then the 4th question, what are the benefits of using a microcontroller? Those are kind of 2 different questions with 2 different answers. But I have said them in the video, so refer back to the video. And how can we provide instructions to a microcontroller? And there's 2 answers to that question, and I'm sure I will have used the words, I will have used it in there. So we'll get in there and look at it, write stuff out. Okay, give it some thought, and then we'll talk about it. End of video 1.